So as I said earlier, we are going to do some practice questions in the Cartesian equation of a plane. Okay, so the first type of question that we are going to see is if they give you 3 points. Okay, if they give you 3 points on a plane, how you can come up with the Cartesian equation of the given plane? That's the question here. So let's say, so how can we do this question? First, let's draw the plane here. Okay, so the plane will look something like this. As we have done so many questions in plane, we can draw the plane like this. So we know A, B, and C are randomly scattered on the plane phi. Okay, so how can we do this? Well, what we do here is, first of all, we will find the vector AB or AC or BC. Okay, any two vectors from these 3 points. Okay, once we have found that, we can actually use the vector product of AB and AC to find the normal vector. Okay, we can find the normal vector by using the vector product of AB and AC. Once we have found the vector product, okay, the vector product or the normal vector, we can come up with the Cartesian equation. Okay, so first of all, let's find out AB. Okay, so AB will be equals to B minus A. Okay, so B is equals to 154. So if I subtract this, I will get -1, 1, and -2. Similarly, we can find out AC also. So AC will be equals to C minus A. So that can be given as 2 minus 2, 0. And we have -1, -4, -5. And 3 minus 6, -3. Okay. Now we will find the vector product of AB and AC. Okay. So AB cross AC can be written down as I, J, and K. Okay, so for I, we have -1 and 0. The order here doesn't matter because we are just finding the normal vector. Okay, so the direction of the normal vector can be either in this direction or in this direction. Okay, as long as we find the normal vector, that's enough. Okay, but it's okay to write down it as AB cross AC. Okay, then we have 1 and -5, and then we have -2 and -3. Okay, so this can be written down as, well, first of all, we have to find the I coordinate. So this will be given as 1 into -3. So -3 minus -5 into -2, 10. So we will get this minus j into, okay, -1 into -3, 3, minus 0 into -2, 0. So we will get this. Then we have plus k into -1 into -5, 5, -1 into 0, 0. Okay, so we will get that. So totally, we will have I, this will be -13. So I will directly write it down as -13I. And we have -3j. And then we have plus 5k. Okay. So this is the normal. Okay. So this is the normal vector to AB and AC. Or we can say it's the normal vector to the phi, plane phi. So once we have found this, we can write down the scalar product form of the vector equation. R dot n can be given as A dot n. Okay. In this case, R, we know we have to write it down as X, Y, and Z. Okay. N is -13, -3, and +5. For A, you can choose either 246, 154, or 2 minus 1, 3. Okay. I'm going to choose 2 minus 1, 3. Why? The numbers are a little bit smaller. That's why. So -13, -3, and 5. Okay, so this will be equals to -13x minus 3y plus 5z is equals to 2 into -13 -26, -1 into -3 plus 3 plus 3 into 5 plus 15. So this will be equal to -8. Yeah, 18 minus 6, so it will be -8. So this can be written down as 13x plus 3y minus 5z minus 8 is equal to 0. So the Cartesian equation of the plane can be given as 13x plus 3y minus 5z minus 8 is equal to 0. Let's see, there is a question where they have given us the vector equation of the plane. We have to find the Cartesian equation of the plane from this. Okay, how can we do that? Well, first of all, if you imagine, okay, if you imagine this, we can draw the plane here. Okay, we can draw the plane here. Okay, let's say the origin is somewhere here. Oh, okay. So 3 minus 1, 2 actually lies on the plane. Yeah. Okay, 3 minus 1, 2 actually lies on the plane. Okay, let's say that is given as A. Okay, and we know 2, 4, 3 is a direction vector. So let's say the 2, 4, 3 direction vector is in this direction, and let's name it as B. And let's name C as 3, 2, 7. It's another direction vector. Okay, we can name it also. So now we have two direction vectors and a point position vector of a point on the plane phi. Okay, so what we have to do is we have to find the normal vector. To find the Cartesian equation, we have to find the normal vector. So this will be the normal vector. How can we find the normal vector? Well, again, we will use the cross product. But in this case, we will use the cross product of B and C. Okay, directly we can do this. Okay, so this is how you have to convert the vector equation. Okay, you have to convert the vector equation to Cartesian equation. Well, let's do this. So we are saying B is given as 2, 4, 3. Okay, and C is given as 3, 2, 7. Okay, and A is given as 3 minus 1, 2. So let's do B cross C first. So B cross C will be equal to, let's write down the I, J, and K coordinates. So that will be 2, 3, 4, 2, 3, and 7. So this will be equals to I into 4 into 7, 28, minus 3 into 2, 6, minus J into 2 into 7, 14, minus 3 into 3, 9, plus K into 2 into 2, 4, minus 4 into 3, 12. So the final answer or the normal vector can be given as 22I, K, minus 5J, and minus 8K. Okay, so this is what we have. Okay, now what we have to do is we have to find the Cartesian equation. So R dot n is equals to A dot n, and R is xyz. Since we are finding the Cartesian equation, n is 22, minus 5, and minus 8. Similarly, what about A? Well, A, okay, for A, you can directly substitute 3 minus 1, 2, because it's a point on the plane. Okay, so this is the position vector of a point on the plane. So you can use 3 minus 1, 2, or you can replace value for S and T to come up with different values, so that you can use it to find the answer. Okay, but in this case, we will directly use 3 minus 1 and 2. Okay, and here we have 22 minus 5 and minus 8. So this will be equal to 22x minus 5y minus 8z can be given as 3 into 22, 66, minus 1 into minus 5 plus 5, 2 into minus 8 minus 16. So this is equals to 55. Yeah, this is equals to 55. So I will write that down. So the Cartesian equation of phi can be given as 22x minus 5y minus 8z minus 55 is equals to 0. Okay, so this is how you have to do, or you have to convert the vector equation of a plane to a Cartesian equation of a plane. Pretty simple, yeah?
Thanks for watching the 30-second video in our vector series. If you found this explanation of converting vector equation of a plane to the Cartesian equation helpful, don't forget to like, share and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos, check out the full playlist to master vectors and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye-bye.